Hello, my name is Florian, and today I want to talk about the four main software engineering activities. No matter whether you are a embedded software engineer, a full stack software developer doing web development, or a front end engineer, every software developer does or should do these four activities. So let's start with the first one. The first one is specifying what the software should do. And you can do this in different ways, right? You can do it in a classical way where you do requirements elicitation, or you even get already requirement specifications from your customer, and then you derive requirements for your software out of these requirements, or you get system level requirements when you talk about a hardware software system, for instance. Another approach is that you elicit those requirements together with the customer. And that's quite often the case whenever you build a software directly for a specific use case that the customer has in mind. Quite often, it's also the case that the customer itself does not know precisely what the requirements are, or that the customer thinks he has a good understanding of what the requirements are, and then during the implementation and the software creation process, you both realize that that's not what the customer wants and what makes sense for this software. So, apart from the classical approach of really deriving requirements in a formal way, noting them down in a requirement specification, something you can do as well is, if you follow more an agile approach, is that you write user stories and that you try to elicitate those user stories together with the customer. The important outcome of this step, no matter whether you do it the classical way with requirements or in a more agile way with user stories, is it in the end should describe what the software you shall develop shall do. Right? So it's really about the what the software should do. The second step that every software developer or software engineer should do is then design and implementation. And I think it's important to also distinguish these into two steps, right? One is design, the other one is implementation. Out of the requirements, out of the user stories that we have from the first step, we now make up a system design. We think about how should we structure our software, what are the different parts. We maybe do the decision what is part of the back end, what is part of a front end, for instance, or whether we implement certain elements in a specific component or in a different one. Maybe this is also the part where we now look, are there already components on the market available that do that job, right? That might be either off-the-shelf software components that you can buy, or open source components that you might be able to use. And that also depends definitely on the license agreement and the license objectives that you have for this project. And you might then also really design and split the requirements in different components that are then easier to implement, and also allocate the different elements of the what to the how, and that would be the design, right? And then after you have done this step, you start with the actual implementation. Now, the design can be a very formal step where you do UML diagrams, where you build a software architecture, but it can also be an informal step where you just draw on a whiteboard or in a sketchbook and then just design your software there. Right? It can even be as simple as writing sort of an outline for the different modules in a text editor, right? So there are multiple ways of designing. It also depends to a large extent on who is doing the implementation, right? If you are implementing yourself the design that you have developed, then it requires much less documentation work of the design than if somebody else should then implement the design that you have developed. Okay, so the third step or activity then after design and implementation is testing, right? Testing and validation. Every good software engineer should make sure that the software that she wrote is working, right? And of course, there might be instances where the actual testing against requirements or against design or integration testing is done and supported by other engineers as well, right? You are not always doing everything on your own. That's perfectly fine, but at least in my opinion, what's really important for every engineer is while you are developing and implementing, already test the software you write. Right? You might not be able to cover all cases there, but it's just good practice and a good standard to ensure that your implementation is really working, right? And that you don't just ship something to the testing department and they come back after an hour saying it's not working and it's not even doing the basic requirements. That would be really bad style software engineering and definitely not what you want to do when you listen here to this channel or here, right? So that's to be avoided. Also, if you then are responsible for testing, or if you're a solopreneur that doesn't have the luxury of having an additional testing department, then you start with the testing, right? The way I usually structure the testing is I start first with the, let's say, normal functionality use case. That means I take the requirements or I take the user story and go through that in the software to check whether the software is doing what has been agreed in the requirements or in the user story with the customer. If that's done, then you also should always do some robustness testing where you do, for instance, boundary tests, right? Or you test with input data that is not expected. So, for instance, if you have built something with a user interface where a user can enter numbers between 0 and 100, then it's a good practice to test with 0, 100, something in the middle, 101, -1, right? That would be the minimum test cases just to make sure that under those circumstances, the software is behaving in the right way. Testing is also something that you should plan roughly the same amount of time than for the implementation. I know that sounds a lot, right? But if you want to really write high quality software, that's usually what it takes. And then you can really be creative in the testing and come up with different cases and so on. And the customer will definitely appreciate that if you just deliver software without faults. The question here, of course, is depending on, let's say, the level of your customer and depending on the level of your agreement, whether you do all the testing prior to showing your prototype or your first implementation to the customer. That might sometimes be actually a good idea, right? That once you have checked these basic functionalities and you know the actual use cases are working, that you then do a customer demo and get the feedback prior to checking all the different boundary cases, because that might be very time consuming. And if the customer already changes his mind after seeing the first demo, the first prototype, um, some of the testing might be wasted because you anyhow have to rewrite the software. That's also a good point to mention here, that if you can automate the testing, especially the regression testing, right, the re-execution of your test cases, that's always worth the effort. You will find in your career that you never just do a test case once. Right? Software will always change, and if it's only the software surrounding your software that changes, it's always worth to think about how to automate test cases so that you can rerun them again, basically for free, just using computation time. And if that's something that you're interested in, please leave comments below, then maybe we can do also a video on that in the future. Now, what comes after the validation and testing phase? After that, we have the fourth phase, which is evolution. Evolution means you write software for a specific purpose. And usually, while you are doing that, or at least while the software is used, the world around you and your software changes. And that means the software requires maintenance, right? That might be because you get new requirements from the customer. That might be because the system that you are interfacing to changes. Or if you do web development, browser technology changes. It might also be simple things like when you have a web shop, for instance, there might be changes in the rules how the invoices are created, right? Because the law changes, because you have new regulatory requirements depending on what you do. If you process data, then there might be data protection laws that change and change the way how you have to document what you do with the data and so on, right? So evolution and maintenance is always something that should be considered from the beginning. That's also why I highly encourage you to have documentation, right? Documentation starts with all the specifications, the designs that you did, right? When you do the design on a whiteboard, make a photo and store the photo somewhere close to the source code, so you have that available. Also comment your source code, right? And then of course also be prepared that maybe somebody other than you needs to maintain the software in the future, especially when you work for a big company. But also, even if you are a solopreneur right now, right, it might be the case that 2 years from now you have employees and you want to give this maintenance work to your employees or outsource that to be able to focus on your new projects. And that works best if you have good documentation. So, in summary, we have specifying what the software shall do as the first thing. That can be done in multiple ways. You can do it in formal requirements engineering. You can do it with user stories. You can build prototypes together with the customer, right? But the important thing is, in the beginning, you have to specify what you actually want to have. The second step is then design and implementation, right? Describing the how the software shall be built and then actually building it. Then third, testing, validation, making sure the software is working, not only that it's complying with the requirements, but also that it is working okay in, let's say, boundary conditions. And then fourth, have maintenance and evolution of your software system already in your mind from the beginning. Every software system will change, and if you prepare for that already, you will save a lot of time in the future. Those were the four main activities in software engineering that I think every software engineer will do. And I will also make videos on the different activities, give you tips on the different steps in the future. If you don't want to miss them, then please consider subscribing to this channel. If you have liked this video, please consider giving it a thumbs up and smash the like button. That always is highly appreciated. And of course, if you have any suggestions or comments, please leave them in the comments below. And I see you in the next video.